In this lecture, we will see excitation table for state machine. If we want to do excitation table, first we need state diagram. Then from that we have to do state table. Then from state table we can do excitation table. Okay. So present we'll consider first we'll consider Murray overlap. Now we'll see the format of excitation table because we already discussed how to do state table state diagram, right, in previous lectures. So now the format of excitation table is we need input x that we taken in the state table, and we need present state and the next state. These also we taken in state table, and we need flip-flops. Okay. Here I taken as example D flip-flops. I will tell the reason why I taken D flip-flops. We can take other flip-flops also. Okay, those we'll discuss later. Here the question is how many flip-flops we have to take. Suppose we know in the state table we can see each state how many bits contained 3 bits. Okay, we encoded each state in 3-bit binary. So 3-bit means we need 3 flip-flops. Okay, so based on the number of flip-flops for each state we decide the based on the number of bits of each state we decide the number of flip-flops. Okay, so now that's why I taken 3 flip-flops. That also I taken D, D1, D2, D3 I named. You can name D0, D1, D2 also, no problem. And output Y we taken in state table, that only I taken here. Okay. So when there are 3 inputs or 3 flip-flops, we will get 3 present states and 3 next states. So this Q1 is the present state of D1 and Q1 plus is the next state of D1 only. Okay, like that. For D2 also, Q2 present state, Q2 plus present next state. For D3, Q3 present state, Q3 plus 1, Q3 plus next state. Okay. So now, how to write these values, we'll see. We know total how many states? 5 states in the state table we got. Okay. We will check the states once. How many states we got? See? Total 5 states. See here. So the first state is 000. When the state is 000, the input can be 0. And when that state is 000, the input can be 1 also. Okay. So like that for each state we can get 2 rows. One is for input 0, one is for input 1. The second state is 001. For 001 it can be 0 or it can be 1. Like that we have to write for remaining 3 states also with a 0-1 input combination. Okay. So now we understood how to write this x, then how to write this present state Q1, Q2, Q3. Now we'll see how to write this next state. Okay. So now we'll go to a state table. So here the present state value, what is the value of present state? 000. And the value of input x is 0. Okay. So now the present state is 000 and the input value is 0. What is the next state here? Because see on the top we write next state. See, this is the next state. So when present state is 000 and when input is 0, what is the next state? S1. S1 means 000 only. So that's why when present state is 000 and the input is 0, the next is state also 000. S1. Okay. Like that we have to write. Suppose for next, when present state is 000 only, but when input is 1, what is the next state? S2. S2 means 001. Okay. See here. When present state is 000 and input is 1, the next state is 001 S2. Like that we have to write for all present state. Based on present state and input, we have to write all next state. Okay. Okay. Now we'll see how to write this input to our flip-flop values D1, D2, D3. Okay. If we use D flip-flop, you can simply write whatever the next state value, same will come here. Q1 plus will become D1, Q2 plus will become D2, Q3 plus will become D3. That's the benefit of taking D flip-flop. Okay. But if you take other flip-flops, you should not write like that. Okay. So why I am writing this next state values as it is in the D values, I will tell. Okay. So we are using D flip-flop, so we need to take a D flip-flop excitation table. Whatever the flip-flop you are using, you have to take that flip-flop excitation table. This is the excitation table of flip-flop. This is the excitation table of state machine. Okay. So we know the format of excitation table. We take present state and next state, n plus 1. So here this n is nothing but this q1 or this q2 or this q2. N plus 1 is nothing but q1 plus 1 or q2 plus or q3 plus. Okay, right. So when see here, when present state with respect, when you writing d1 value, when present state is 0 and next state is 0, when present state is 0, next state is 0, what is the d value? 0. So if it is q1 plus, this will become d1. So 0. And when present state q2 0 and the next state is 0, again 0 we will get, see here 0. And q3 also 0 and q3 plus also 0, again we'll get 0. Okay. So from this excitation table of D flip-flop, we can observe whatever the next state, that will be the D. That's why whatever the next state, I am writing as D. Okay, this is the benefit of using D flip-flop. We can easily write next state values in the D. Okay, because this excitation table Q1 plus 1 same as D. But in other flip-flops, it is not same. So we have to check according to 0, 0, then only we have to write. Okay, right. Now we'll see how to write output value. Okay. So here in the output we can get only at 1 place 1. That we have to identify. At remaining places we can simply write 0. To identify 1, you must see state diagram, not a state table. If you see state table, you will get confused. See, when we getting detection 1, when present state is S4, okay, and when input is 1, we are detecting. And the next state is S5, we are detecting. So we have to look for S4 when input is 1. S4 when input is 1. So S4 means 0, 1, 1. Okay. And input is 1. So we have to look in the excitation table 0, 1, 1. So this is 0, 1, and here input 1. At this place we are getting output 1. Remaining all places we can write 0. Okay, right. Now we'll see excitation table of Moore and non-overlap. Almost excitation table same as previous, but only one little difference. The format is same. Okay. The only one difference is here this state. Now we will compare this state table of Moore and Mealy so that we can understand the what's the difference in the excitation table also. Okay. So here what are we getting? 1, 2, 3, 2, 4, 2. Now we'll open overlap. See here what we getting? 1, 2, 3, 2, 4, 2. Same we got for first 3 states. Remaining states will see 1, 5, 3, 2. Now we'll close this. See now 1, 5. And what is the last one? I forgot. I will see again. More overlap. 1, 5, 3, 2. Now here what we got? 1, 2. So this is changing. Accordingly, we have to write here. So now here, when present state is 100 and the when input is 0, we have to write 000 because S1. So for 1000, we have to write 000. So for 1000, we have to write 000. This is the only change. Okay. And output accordingly we write. We will check where is the output to becoming 1 from the state table. State diagram. Okay. So when present state is 4 means 011, and when input is 1. For 0111, we are detecting. For 0111, 1. So this is 011 and 1. So at this place we are getting 1. Remaining all places we can write 0. Okay, right. Now we'll see mealy type excitation table. For mealy overlap, so here excitation table little different compared to previous. The reason is here we get only 4 states, not 5 states. No? So for 4 states we just need 2 flip-flops. So here also we get 0 0. For 0 0 it can be 0. For 0 0 it can be 1. So only 2 flip-flops. So only 2 present states, only 2 next states. This is the difference we have to observe. Okay. Remaining, as usual, we will write. However, we write input, present state, next state, inputs, D1, D2, and Y. This is same as previous one. Okay, according to that state table and state diagram, we have to do it. Okay, we'll check when this output we are getting 1. See, we'll check. See here, whenever present state to S4 and input is 1. S4 1. That we have to see. S4 means 1 1. For 1 1 1, we have to see. For 1 1 1, we are getting 1. Remaining all places we can write 0. Okay. Now we'll see the excitation table for mealy non-overlap. It is almost same as previous, but a little different. I will show you. So here, what are the states we got in the state table? 1, 2, 3, 2, 4, 2. Now we'll check in mealy overlap. 1, 2, 3, 2, 4, 2. See here, 1, 2, 3, 2, 4, 2. But what is the last one? 1, 2. We'll see that. So last one is not 1, 2 here, 1, 1 here. So this is only changing. So accordingly, we have to write. Okay, that's it. No other difference. And we'll write output when we getting as per state diagram. Okay. So excitation tables completed for all state machines.